So the idea here was to have a conversation around small and mid-scale LNG. You know, we talked a little bit about this morning about how we see lots of opportunities there, a lot of activity there. There are lots of companies that are active in this space. We have at least a couple of them here. So very quickly, we on this particular panel, we have from the left Blake Roberts. Blake until recently used to work for IHI E&C, was fairly involved with commercial development, business development of a lot of projects in this particular space. He's currently an advisor to ADI. Then we have Travis Bowman from Dresser-Rand Siemens, part of the Siemens group. Travis is intimately involved with the Dresser-Rand LNG technology, the microscale LNG technology. Then we have Bob Salmon from GE, actively involved in developing projects in this particular space. And then finally, our colleague again, Vis. Vis will talk a little bit about some of the work that we have been doing looking at emerging markets for LNG in the small and mid-scale. So maybe with that, Blake, maybe if you can kick us off here with a few thoughts, and then we can go from there.
So I guess good morning or good afternoon. First of all, I'd like to congratulate ADI on their first conference. And I know you guys put a lot of work into getting this thing kicked off, and it's quite a big effort, and congratulations on that, and wish you guys much success in the future. I'm going to talk a little bit about LNG project development. Okay, we've had a lot of good discussion about LNG projects, but I want to give an overview of kind of historically how projects were developed and kind of talk about this midstream or mid-scale LNG. You see it thrown up on the screen, mid-scale LNG. What does it really mean? Well, let's just take a little look back at history. So the LNG from a project development standpoint has typically been baseload LNG, and baseload LNG typically is very large natural gas resources that are stranded, okay, and then you've got a buyer, primarily started out in Asia and then the UK, and the Asian buyers would contract for a certain amount of LNG, a very large volume. There'd be a very large capital investment made for a stick-built project, and the project just started out around 3 million tons a year, and they've grown up to single trains of over 7 million tons a year. And the costs have just gone out the roof on some of these projects. Gorgon's $40 billion, I think, something like that. And so maybe more. But so that's historically baseload LNG. So it was a stick-built facility. It was stranded gas. It had transport involved on large LNG tankers, and it went to a market. Okay. And then that's one side of LNG project development. The other bookend really is small-scale LNG, which has typically been for peakers, peak shaving, and then historically, because of the spread from diesel to natural gas, there was a big push for LNG for motor fuels. So that's kind of the small scale LNG. So in between, you have this new term, which is called mid-scale LNG, and it's been kind of loosely defined over the years, and people didn't really know what it was. Over the last 2 or 3 years, I've been involved in project development in this space. And as we started working on these projects, and we talked to more project developers, and then we talked to equipment suppliers, a few themes started emerging. And as a result of that, we were trying to really understand what mid-scale LNG meant. And so we wrote a paper on mid-scale LNG, and it was published in the LNG Industry magazine last November. And then the title of it was Midstream LNG, A New Reality. Okay, so where was this new reality coming from? And it was really coming from all the learnings in the midstream business in the U.S. We've talked about this earlier. The last 6 or 8 years in the U.S., the midstream business has just exploded. And there was just gas plant after gas plant after pipeline built. And it was built with a couple of main drivers. And the main drivers are kind of driving what we think is really the mid-scale business. So we define mid-scale LNG not as a capacity per se, not 3 million tons, not 5 million tons or 1 million tons, but really more of a project development mentality. And so what's driving that is really the learnings from the midstream project development. Key things, standardization and modularization. Okay, and what does that mean? Okay, so What's happened with the modularization of LNG is it started out building very small liquefaction plants, but now it's kind of emerged into a block capacity of anywhere from 0.25 million tons per annum all the way up to, say, 0.8 million tons per annum. And the larger stuff is being labeled as mega modules. Okay, so a lot of these projects that I'll talk about a little bit are using these mega modules, and Bob Salmon with GE, I've worked closely with the last few years, will talk about what they're doing in that space. So it's about standardization. Standardization means not letting an owner dictate all the standards of all the bells and whistles and what they want. It talks about setting a standard design, just like a gas plant or a cryo plant, where you've got a 60, a 120, a 200. So you got a standard off-the-shelf design. Parallel activities. So when you get into project development, when you can actually do your engineering and do your construction off-site in a controlled environment, you can control the cost, control the quality. You can also do your site activities at the same time. So when they come together, you've got a shorter overall schedule. Lean execution, really just a mindset. Letting a standard design take precedent over a very detailed design for a very specific location. And the last thing, the biggest thing is low cost and repeatability. A lot of these projects that are coming along, they start out, the game plan is to start out at, say, 1.5 million tons, okay? And then from that, you add another module to that, so you might go to 2.5 to 3. One of the biggest challenges, and there was a lot of questions in the last session about, which projects are going to go forward, which one's got the advantage over the other. What drives the LNG project to sanction, to FID, to completion, is a buyer, okay? And I will tell you, from past experience, it's very difficult to sell 7.5 million tons of LNG in one block. But it's a lot easier to monetize or sell 1.5 million tons. So people have learned over time that, hey, maybe let's do this in little blocks and chunks and build it out versus trying to do it all at once. Okay, let's see. So that's kind of our definition of mid-scale. It's more of a mentality than an actual capacity. Okay, so what's really driving, mid-scale? Big thing, we've talked about it, mega project overruns. And when you get into project finance, when you get into banks, they like certainty. And the industry's done a very bad job of controlling cost on these mega projects. And what happens is the engineers get involved and they think bigger is better, scale's better, unit cost is down lower. But at the end of the day, you just can't manage it, and it runs away from you. A lot of the big projects are built in remote locations, which means you got to bring in labor and everything else. So the logistic nightmare of building the mega projects. So also the increasing market liquidity. We just saw a slide that showed over 30% of the LNG is really spot markets. So that's kind of a thing that's evolving and changing. And the financial markets, really, they have an appetite for smaller chunks, $1 billion, $2 billion. The private equity that was invested in all the midstream, they like that model on something that's a little bit smaller, a little more manageable, okay? And I mentioned earlier, it's really a lot easier to sanction a project on 1.5 million tons versus 5 million tons or 7 million tons. So that's really the overall drivers for mid-scale. Next slide is, this is some actual projects that are using this business model. First one, Energy World, they've just proposed a project in Port Fourchon in Louisiana. And it is an exact carbon copy of what they've done in Indonesia. They're using Chart Siemens technology. So their plan is take the exact same thing we've already done and just do it again, okay? Also, what's interesting on some of these smaller projects is these entrepreneurs, they actually bring the actual market with the project. For example, Energy World, they actually have gas-powered plants around the world, so they can actually be a buyer for their own project. Elba, that is a project that IHI is the EPC firm on. It's using GE modules. Those are a little unique. It's 0.25 modules, 0.25 MTPA. They're putting 10 of them together, okay? And that project is actually under construction. We talked about Summit LNG is actually a British Columbia project that's using the mid-scale approach. And if you haven't heard about the project, there's not a whole lot out there, but they want to circumvent the actual pipeline costs by moving the LNG on rail cars and having unit trains like they use unit crude trains. They want to use unit LNG trains. So you build your LNG liquefaction facility inland, okay, right next to a pipeline, so you don't have a pipeline cost. You transport it over a train and you to an export facility. When I was first introduced to that project, I said that just doesn't add up. Well, if you really start looking at the economics of it, it's a viable project, okay? Driftwood LNG, which is Tellurian, all of their stuff is small segments at 0.8 million ton units and build them out. Same thing with Venture Global. Same thing, small capacity chunks and you build it out. And those projects, Driftwood and Venture Global, their mentality is we don't need a big EPC firm to do all the detailed engineering. We're going to pretty much do it ourselves, and we don't need a feed study. We don't need a competitive feed. We don't need all this stuff. We're going to just basically go for the lowest cost production capacity, and we'll be the most competitive in the world. So that's kind of an overview of some of the projects, and that's really all I've got.
Okay, hi, my name is Bob Salmon. I'm the sales manager for our GE gas processing business. I'm based here in Houston. What you're looking at in that photograph right there is inside our factory just outside of San Antonio, and this is where we do a lot of the fabrication and design around our small-scale industrial refrigeration plants. These are modules that are being fabricated for Shell for the Elba Island project. And I'll talk to you a little bit about that as we go forward. So our business, gas processing, we sit within the turbo machinery group within GE Oil and Gas. GE Oil and Gas is about $15 to $20 billion business. As you might have heard, we're now merging that with Baker Hughes. So by the middle of this year, there'll be a new company created. So probably the structure will change somewhat, but our turbo machinery business, that's where all of our big gas, air-derivative gas turbines, heavy-duty frames come out of, as well as a lot of our other rotating equipment, our compressor solutions. We get a core of our business in Italy and quite a lot around the world. So in terms of GE gas processing, so what we encompass are 3 different product lines. The core of our expertise is really around industrial refrigeration. And within that, there's three segments that I'll talk about. The LNG segment, we have a small-scale LNG business that goes up to mid-scale. We've got a CO2 business, and that's really the legacy core of this company. That's where we developed our expertise on doing refrigeration, doing modularized designs for plants. And then the other part of our business is around gas processing. And this isn't the more commoditized gas processing segment where Exterran and Enerflex dominate, but more niche applications and some other types of industrial refrigeration. Like we've done ethane chillers, we've worked on ethylene projects, other things that leverage some of our expertise. The core of what we do is a modularized design versus a field-directed stick-built design. And there's some variation in terms of what modularity means, but that's really what the expertise of our business is. Now, we've got, as I mentioned, most of our experience was built in the CO2. We've leveraged that as the small-scale LNG market and mid-scale has developed. We've leveraged that expertise to grow into that space. In terms of the markets that we focus on, there's 2 that I'm going to focus on LNG in the next few slides. The drivers for the other markets, CO2, gas processing, are completely different. But for the purpose of this discussion, I'll focus on LNG. And there's 2 main markets that we look at, the domestic as well as the export. Now, on the domestic side, you've got the high horsepower markets, which is really a diesel displacement that's really an arbitrage game. It's a very, very small market today. There's not a lot of opportunities for diesel displacement for all the reasons that have already been discussed today with the price of oil. But that would be rail, mining. You've got some long-haul trucking, other applications, some small pilot projects. The other market on the domestic side that is probably more opportunities, marine, which has been discussed, and gas to power, right? It's nothing to do with the diesel price necessarily, but there's a lot of smaller plants in the Caribbean, in Africa, around the world, places that need gas, can't get it, and so small-scale LNG is an opportunity to fill that need. The other market that we focus on is the export sector. Within big GE, we've been supplying the big compression trains for LNG plants, ConocoPhillips, APCI, for decades. What we're seeing today, as Blake and others have discussed, and I'll get into it in a little bit, is the change in the business model for some of these plants. And what we're seeing is a convergence between a lot of the modularity, expertise, and the different processes in the small scale, and kind of being combined with the larger scale to create this mid-scale space. Now, getting into what our typical solutions are, just to be clear, we're not an EPC. So what you see there is a small-scale LNG train. This train in particular was built for Shell, the first one we did for Shell. This is sitting on a back pad outside of our facility, just outside San Antonio, where we did basically a factory acceptance test. Now, this train is 450,000 gallons a day, which, if you like MTPA, that's 0.25 MTPA. Our typical scope within an LNG train encompasses the pretreatment side, so taking the gas that's coming in, cleaning it up to take out your water, CO2, H2S, other contaminants, BTEX, and so forth that would freeze up in the cold box, and then liquefying it. So you've got on the bottom side there is the cold side, the warm side of the plant. On the upper end is where you see on the left-hand side the air coolers. On the right-hand side, the two compression trains. That's where the liquefaction takes place. That's pretty typical for a small-scale plant. This is just one configuration that we have. Now, the way we approach these projects, we have structured product designs that we use. I wouldn't use the word standard because there is no such thing as a standard LNG plant. Everything has to be customized to some degree, but we try to have a structured design that we can leverage for each project. But each project has its own project-specific variables that we look at and analyze, and we match that with a process design. We have our own liquefaction processes, from single-cycle nitrogen, methane, single-cycle mixed refrigerant, and a pre-cooled cycle. So we match those project variables with the process for that particular project, and then we decide what the right equipment selections are going to be to create a safe and efficient solution. Now, we've got a facility, as I mentioned, outside of San Antonio where we do these kinds of modules. Now, you can't see them very well here, but these are truck-sized modules that fit in the back of trucks. And this facility we use to serve not just LNG, but we do our CO2 plants out of there. We do other industrial solutions as well. The modules that we do for truck size, some of the modules for CO2 plants are really just skidded equipment. So for this plant, for Shell has a lot of very specific requirements, as many of you may be aware of, unique to Shell. So there's a lot more design that goes into this train than for some of our smaller facilities, which tend to be more CapEx sensitive, and we try to take out some of the bells and whistles. So modular design. So what you see on the left, that's an example of one of the skids that we did for a CO2 plant. Pretty typical. It's one CO2 plant. Total CapEx might be $20 million, right? So these are pretty small. Might have 4 or 5 skids, an electrical control room, and some storage, offloading. Pretty simple. On the right, this is a big mega module. Now, with our LNG markets today, we've leveraged some of this experience that we have doing this is a power gen module, so doing large mega modules for power gen, and we've taken that experience to bring it into the LNG space for mid-scale. We've seen the demand for these export plants, as Blake mentioned, looking for different business models where they can take out some of the variables in their project that are driving up cost. So the benefits of modularity, when you think about it, the reasons that clients choose a modular design is to help control their labor costs. So in many places in the world, labor is constrained or expensive. We take a lot of this field work, we bring it into a factory environment. You get higher productivity there. We have the same labor force, same welders that are doing this work on a repetitive basis. You're in a factory-controlled environment, so that generally benefits the safety of the project as well as the schedule, right? You're not at the whims of the weather and so forth. And at the same time, as we're doing some of the modular design in our factory, the EPC can be preparing the site, taking care of laying foundations, and they can optimize their schedule so they can minimize the amount of equipment they have at the site. So they'll know when the modules are coming. They can then arrange when they need craneage. So it helps bring the overall project schedule and the cost down. Now I want to talk a little bit about the market. Yeah, I'm sorry, go ahead.
The mega modules that you talked about, are they for land transport within the U.S.?
No, so again, this is actually, that photo you see there this is a mega module power gen that actually went to Gorgon. We have, the biggest train we do today is about a 0.6 MTPA train. It's much smaller than that in a modular size, but it's still about 1,500 tons, right? It's a single liquefaction train. It goes on a vessel, and then that site where it's going to must also be water-based to be able to transport it there. So if that answers. So we've talked a lot of it about this today. So the last couple of slides I have are just on our view of the market, and I won't beat a dead horse here, but I think this complements what Tyler was saying, what Blake was saying. If you look at that chart on the left-hand side, all those bubbles, those are LNG projects. And there's a significant cost reset going on today because of the oversupply of LNG. You can't do these large projects with huge cost overruns. So you have a lot of projects that are trying to develop new business models, and they're moving down into that kind of gray rectangle area. The plant costs have to come down. You see everyone talking about dollars per ton and getting it much lower than it's been historically, right? Much far under, $1,000, not even $1,000 a ton. People are talking at $500 a ton or less in some cases. None of those projects have realized that yet. These are concepts and these are new business models, but it's a significant disruption to the industry. A lot of these projects are in North America, but we are seeing a lot of opportunities, a lot of clients that we're talking to in other locations as well that are looking at more of a mid-scale model. So what does mid-scale mean? So we've all got different definitions. There's nothing standard about what mid-scale means, but for us, the way we see this is, as I said, it's kind of convergence between taking the small-scale LNG mentality for a project and combining that to produce a large export facility. So these are generally still big facilities. Venture Global, for example, working with them, they're looking at a 10 MPA facility. So that's a big baseload facility, but they're doing it with 18 trains that are about 0.5, 0.6 MTPA each. So why are they doing that? Why would anybody do a big plant with a lot of small trains? It doesn't seem to make sense, right? If you're used to APCI, you'll say that's stupid. It never going to cost, doesn't even make sense. But they have a much different approach to the technology and the process. With the large processes, they're highly customized, very expensive equipment. The business models are looking at the complete life cycle cost, right? We're looking at smaller. These projects in mid-scale are looking really at the first CapEx. They're project finance led, and they're focused on smaller offtakes, right? Today, it's very hard to sell a large offtake, so if it wasn't, everybody would probably stick with the large, more traditional cycles. But you got power projects that are looking for 500-600 megawatts. That's a much smaller offtake. And if you're putting 10 or 20 of these together for your mega liquefaction train, it becomes very hard to operationalize that. So you even got Cheniere looking at smaller train sizes. So we see this as a trend today. We're heavily invested in the big trains as well as GE. We play both sides of this, but we think this is a sustainable trend in the market going forward. So some of the solutions, as I mentioned, these new developers are looking at more modularized solutions, less site-specific construction. They're looking at more simpler equipment, more standard vessels and so forth, raised aluminum heat exchangers instead of these very massively expensive spiral-around heat exchangers. They don't need 10 different cascades and pre-cooling cycles, just simple cycle, mixed refrigerant. Hey, if the thermal efficiency is within 10% of one of the big cycles, it's good enough. So that's the mentality. And then, as Blake was saying, the faster, leaner execution. So hopefully didn't go too long, but in a nutshell, that's kind of where we see things going.
Okay, good morning. So my name is Travis Bowman. I worked for Dresser-Rand for about 10 years before we were purchased by Siemens. What we're talking about here is micro scale, so 0.01 megatons is the biggest that this gets. Obviously, you could put multiples in and go up a little bit, but it's not even really small scale at that point. It's just a list of everything we're going to run through. Try and make it quick. So distributed LNG demand side markets, right? So where we see our demand is going to be in small consumers, could be mine trucks, could be remote utilities, northern Canada, the Caribbean, these places, they have power generation, but it's not a lot, right? So you don't need a lot of gas. So we see those as our demand side markets. CNG doesn't particularly work for a mining truck. You can't get enough BTUs on the truck. So LNG kind of fits in the mining space a little bit there. On the supply side, we get inquiries from flaring, like in the Bakken. Can we liquefy that gas? Because they don't want to put in the pipeline infrastructure potentially. So that's another one. Or in the Marcellus, there's a lot of capped wells. Maybe they want to bring that gas to market, even create it on their own by putting in remote power generation somewhere in a small remote village and then bring it up from the Marcellus. So those are some of the things we kind of get into. This is our low pressure system. It makes about 7,000 gallons in the pictures there. That's what you're seeing, which is 11 tons per day. So it's redeployable. You do have to put in some foundations, but it is redeployable. You can pick it up and move it. We also have an HP system, which we'll get to. Makes about 48 tons per day. Throughout this system is Dresser-Rand compression, Siemens technology as far as motors and drives. And basically, we use the client's gas as the refrigerant cycle. It's a pretty complicated slide here. But what you're seeing is the difference between the LP system and the HP system and the equipment that's involved. So the LP has no feed flash compressor. They both have a primary compressor. They both have a process module, turbo expander style plant, and then they both have controls modules. In addition to that, we do some gas cleanup. We do a temperature swing absorption on the high pressure. We do a pressure swing absorption on the low pressure to clean out the last of the water and CO2, basically. So it's basically a polisher. We provide power modules where we burn the tail from the gas conditioning to make power along with some of the raw gas. And then we can contract LNG storage and balance of plant as well if a developer is interested in that. Here's kind of the data on these things. So you're making a saturated liquid LNG. So you're making anywhere from 7,000 to 25,000 gallons per day, which is 0.01 or 0.004 megatons per annum. Very small capacities. Main difference between the LP and the HP is the inlet raw gas pressure. So the LP system takes in 35 psig, which is nice for like a well site. Maybe you're running a JT skid. So the advantage for taking in low pressure is there. High pressure side, you're getting thermodynamic advantages. You can put that on a pipeline and take advantages on that side. Another look at the 4 modules of the LP: conditioning module, power module, compression module, process module. So that's just sort of the solid model there. This is the solid model of the HP unit, making about 2 megawatts worth of power, treating that gas with the temperature swing absorber, turbo expander style plant, can produce about up to 30,000 gallons. We're a little bit at the mercy of the gas that the customer wants to liquefy. But as others have stated, we don't modify the process very much. What I do is run simulations and say, hey, if this is your project, this is where we can get you with our equipment, and they take that and run their economics. This is a PFD of the cycle here for public consumption. So basically compress the gas after we do a little cleanup, turbo expander style plant, goes into a flash vessel. There is a pre-cooler on this loop, so we pre-cool the gas before we expand it, JT valve at the end into the flash, and then we have LNG. This particular schematic here is the low pressure system. High pressure system similar, except we're doing a closed loop and an open loop side, still a pre-cooler with propane, 2 compression units. We take back the flash gas, utilize the cold there, recompress and send it back up front. This is our demonstration unit in Pennsylvania. So this is at our facility in Painted Post, New York. Sorry, this is in Painted Post, New York, which is where Dresser-Rand has a factory, a compressor factory. We put this unit online in 2013 and finished some R&D and then actually moved it to Pennsylvania. These are our current projects. So we have the one in New York, which line 1 and line 3 are actually the same project. We moved that unit and sold it. Line 2, British Columbia, is an HP project. In New Jersey, we have 2 more LP projects. That particular project has no gen sets. We're actually re-injecting the tail to the pipeline on that project, and they are using grid power. And on the right there, you can kind of see what the customers are using the units for. 2 more in Canada, stranded gas assets, basically. There's just some photographs here at the end. So this is Pennsylvania. This is New Jersey. This is northern BC. This is a high pressure unit. And just kind of wrap it up here for you. You know, these units produce between 7,000 and 30,000 gallons, which is 11 to 48 tons per day. You know, it works well for local LNG production. We've seen demand for IPPs, you know, that have interruptible supply, that just want to make LNG as a standby. We see a lot of power generation, I would say, is probably the biggest driver we see right now. We have the shortest cycle time to operation, multi-market applications, worldwide service and support with Siemens. Inside of this unit is basically all components that were already in play for Dresser-Rand or Siemens. So the Moss compressor is used in booster stations on gas pipelines and other various applications. The Guascor genset is our engine manufacturer out of Spain, which is used in biogas applications and any other power applications for recip power. These are the codes that were sort of adhered to. You know, we considered mainly North American codes, but we're working projects around the world. CRN, CSA, GOS standards in Russia, whatever the standards may be. You know, we modify the design to meet the standards of the country we're working in. And that's my boss. Feel free to contact. That's all I've got.
The small and mid-scale LNG, I want to look at it from the point of view of transportation applications. They're mainly related to the trucks, trains, and the marine industry. The main driving force is the regulations. I'd like to correct Taylor. The sulfur regulations are coming into force in 2020. IMO made a resolution recently. They preponed the 2018 decisions it still has to be ratified by the member states. And the general feeling is that it is going to be ratified, so the sulfur regulations are coming, which is that from 3.5% sulfur worldwide, you have to use 0.1% sulfur. 0.5% sulfur. And the 0.1% sulfur in ECA areas, environmental control areas, are already being enforced from 2015 onwards. So the sulfur regulations are going to play a major role in bringing the sulfur dioxide emissions in the marine industry. And the LNG fits in this role perfectly. So does methanol. We also have to look at methanol, since the methanol produced from the natural gas. And essentially, both methanol and LNG don't have any sulfur, so you get rid of almost 100% of the sulfur emissions. NOx emissions are reduced by about 80% in both cases, mainly because you can operate the engines at a lower temperature. And particulate emissions, carbon, which is a problem even with low sulfur diesel, are reduced considerably, something even to the extent of 95%. So LNG is going to bring in a large change in the marine emissions in general. However, the marine industry is pressed for capital. They are afraid that somebody using heavy fuel oil is going to have an economic advantage in their operations. So Wärtsilä has come in with dual fuel engines that can operate both on natural gas, which is LNG, as well as the marine gas oil and also or heavy fuel oil, so that you can use any one of these fuels based upon the economics. And they also provide the scrubber, so that you can use the heavy fuel oil and get the scrubber out. So the small and mid-sized LNG plants fit this role very well, because they can supply a fleet of trucks or trains or ships with the required LNG. And they would prefer distributed supply to large-scale LNG plants. And the other advantage I see is that while the large-scale LNG plants usually have delays and cost overruns, the modular small-scale and mid-sized plants, they have an established design, so there is a fair amount of cost control. And the other thing is that there are already about 80 to 150 ships operating at LNG in Europe, in the Baltic Seas. So the experience is there. And if you look at, in general, and they are also, Europe has plans to install over 100 small-scale LNG plants at different locations, so that they can supply the ships at these points. So that is one point. And then methanol fits this role perfectly well, because methanol is compatible with the diesel fuel oil systems. And the conversion of the engines to retrofitting the engines to methanol is simpler and cheaper. And there is already one ship operating in the Baltic Sea using methanol that was done in 2014. So that is feasible. For whatever reason, it is not picking up. And my own feeling is that come 2019, just before the IMO regulations come into force, we will have a great amount of activity for conversion. And it is anticipated that most of the new ships will go for LNG. And how the methanol comes up is something to be seen. But methanol is cost effective. Methanol could also be used for power generation in Africa and Asia.
Okay, thank you. It's just so maybe we'll start off with a couple questions and then open it up to the audience. Maybe for both Bob and Travis, can you guys comment on what is the capital cost of each of these plants? Maybe as a range, if not necessarily actual numbers, or at least provide some sense of the cost competitiveness of these plants.
Sure. So I'll talk about, depends on the plant size, obviously, but with the large export plants, they typically talk in dollars per ton, so I'll use that, although it's a imprecise metric because some plants are greenfield, some are brownfield, there's different infrastructure requirements. But when you look at liquefaction, which is what our core is, and we do pretreatment as well, but if you take liquefaction and pretreatment for a facility that's, let's say it's a big facility, 2 to 4 MTPA export capacity, we might be 25 to 30%, roughly speaking, of the overall total install cost. So, you can do the math from whatever your dollars per ton are. There's a big range in figures out there, but I'd say your liquefaction and pretreatment, you're looking at about a third of that. So if you're at a $500 a ton cost, that's roughly 150 or so.
Travis, can you comment a little bit on the cost structure, cost competitiveness of your plant?
Yeah, I think so. I think in general, when you say LNG or natural gas, and then you want to talk about liquefying, what is in that gas drives a lot of that cost, right? And then the scope of that plant, the liquefier itself is going to be on parity or slightly above at a micro scale than a large plant would be. Obviously, there's economies of scale gained, when you run a large plant. But another factor is, if you're off pipeline, the cleaner the gas, the cheaper the project, right? So, it's a question, I think, sometimes of some external factors to the project that sort of drive that cost, But these are in the tens of millions of dollars, They're not in the hundreds of millions, obviously.
So that would mean that Marcellus probably is a great place, right? Marcellus gas comes out right at the right calorific value, is dry, it's like relatively clean, and so why aren't we seeing, I guess, more uptake, let's say, given the fact that there's so much dependence in the Northeast on heavy oil for heating and all that?
Yeah, there is. I think the game is always, as others have said, you have to find that customer first, right? Then you have to back into the relationship between where the supply is and where that customer is going to be. And then you can start to piece together the economics as to whether or not you can take that gas from the Marcellus, to someone who needs it at a price that'll move, right?
Right. So, Blake, can you talk a little bit about what are the key challenges or barriers that you see for small mid-scale, like the top 3 challenges and barriers that you see for, I guess, greater adoption for small mid-scale in North America?
I think the biggest option is always, finding a market. And I mentioned earlier about some of these projects bring a market, and that's the beauty of the smaller capacity. You don't have to have as big a market. So the market is always the biggest. Next barrier would be, financing. A lot of these projects are entrepreneurs that are financing them. So one of the things you see with project finance is, is this serial number 1? Is it serial number 2? One of the things that a GE brings to the table is potential equity in a project or potential financing, and so people like to developers and bankers like to have the right companies involved. Another big thing is an EPC company that actually can provide a process guarantee or an EPC wrap on the whole project, a guarantee that it's going to produce and start up when they say it's going to start up. So all the challenges of of a large project, but the challenges because of the size seem to be a little bit smaller.
Okay. So maybe we'll open this up to the audience right now and a few questions, Sean.
Yeah, when you go to small scale, you're talking about, scaling down the plants, but the port facilities can't be scaled down the same way. You can't have, scale down the ships that are coming in. There are a certain size ships, and you have to be able to fill them at the same rate that they expect to be filled at any port. So you have, all of your harbor facilities are going to be the same, unless you're going to talking about the mega scales. But if you have a small plant producing, you still have to have a large storage capacity, and you have to have the ability to load and bring in to the channel, the marine channel. So that you're really going to miss some economies of scale. I think there's a little bit of over-hype on, we're going to downsize these things and everything's going to, be a lot cheaper. No, you're a big chunk is still going to be
Exactly.
the same
So
cost.
yeah, just to answer that, you're going to have, the numbers are coming in for a total project cost of the 600, plus a ton. So yeah, it's not half price, but it's a haircut maybe of 25-30%. But the big thing is actually being sanctioned and actually having a project versus not having a project. And so the big driver really is the size and the nimbleness of the actual construction versus the overall cost.
And so that was I just had a comment because I've heard seems like it was needed to be metered a little bit.
Right.
But the question I have is, what is the relative gas shrinkage for a small scale, mid scale, and large scale projects? How much, if you have a stream coming in at 100 molecules, how many are going to make it out in these different size projects?
Do you want to address that? I mean,
Yeah, I mean, there's not a lot of shrinkage. I can't give you an exact number. I mean, it depends on what's in the gas and so forth. But when you're dealing with typical pipeline gas in the U.S., you got pretty high methane content in the pipeline. So there's really not a lot of shrinkage.
yeah, they're not sufficient. A mid-scale plant, is probably not going to have propane pre-cooling or something. So your overall efficiency might be 5 or 10% less than a large-scale APCI project. But in the overall scheme of things, it's about getting a project versus not getting a project. So yeah, it's not as efficient as a larger scale project.
Yeah.
Question about in your modular plant, what do you do for, how do you dispose of the acid gas? That's one question. Number two, on a 1 million ton that you showed, what is the size of your turbine, horsepower one?
Okay, so on the first question, for the large scale plants, we typically, when we have multi-train facilities,
Your sulfur
The-
one.
you're asking about the acid gas removal
Yes.
system, right? So that's a pre-treatment. What is more commonly done is there's a common pre-treatment. So we can do that. Sometimes the client wants an EPC to do that. It's pretty much standard industry solution.
How do you dispose it off? Like in the large scale, you have a sulfur plant, sulfur recovery. In a 1 million ton or a 2 million ton plant, how do you dispose of that acid gas?
It depends where you are. Some places you just vent it. Some places, if you have a gas turbine driver solution, you can take some of that waste.
You just say high
Covered.
sulfur gas?
Say again?
It's going to be high sulfur, right? Very high. You're recovering hydrogen sulfide, carbon dioxide. How are you going to dispose it off? In a big LNG plant, you have a recovery.
Well, if you have gas turbine drivers in a mid-scale plant, it's the same thing.
You meet the emission requirement?
Yes, we're always going to comply with the emissions requirements on it. That's not
So
hard to do.
what the order of magnitude of the turbine size you're looking at for a million ton?
So for our solutions, the largest train we've designed fits with an LM2500, which produces about 0.7 million tons per annum in single train capacity. That's the largest that we've designed with a GE process.
How much, what are the megawatts?
0.7 MTPA capacity in terms of megawatts for that train, roughly 33 megawatts.
So let's thank the panel. Thank you very much for